Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hi, everyone, and welcome to the SEI Podcast Series. My name is Dr. Rachel Dzombak, and I'm a senior advisor to the director of the SEI's AI division. Today, we are here to talk about the potential uses of large language models in the intelligence community. Earlier this year, the Office of the Director of National Intelligence, spurred by a request from the White House, reached out to the SEI's AI division to explore use cases for large language models and national security, specifically within the intelligence community. Between May and September of 2023, a team of researchers in the SEI's AI division attempted to determine if and how tools built on top of large language models might be customized for use by the intelligence community. The team also explored the trustworthiness of such tools in this realm. Joining me today to talk about this work is Dr. Shannon Gallagher, who is the AI engineering team lead. Welcome, Dr. Gallagher.
Thank you, Rachel. It's a pleasure to be here today.
I'm so excited to jump into this conversation. Let's begin by having you tell our audience a little bit about yourself and what brought you to the SEI.
Yes, so I've been working at the SEI for 2 years now. I'm a machine learning research scientist here, and I'm also the team lead of the research scientists in the AI Engineering Center within the AI division. What brought me here, I like many people at SEI, I have kind of a roundabout way into public and government research, but it was really quite wonderful. I did my PhD in statistics at CMU and did that in 2019. And my thesis was actually about modeling infectious diseases. So as you can imagine, it took a little a way to get to use was for government, but made it here to SEI, and it's been very, very exciting place to be, especially working with large language models and generative AI in general.
Great. Well, we definitely today will talk about generative AI and large language models, and maybe just for fun, we'll talk a little bit about the connections you see between infectious disease and computer science as well. But let's start out by jumping into our exploration of large language models for national security. So since OpenAI released ChatGPT last year, there's been a lot of attention and press around the use of large language models in different contexts. Can we set the stage for our audience by explaining what is a large language model?
Yes. So, Rachel, one of the things that we really wanted to take a look at and set about in Mayflower, which is the project that we've been calling about this large language models research, is how can I, as a layperson or have some knowledge of AI, what can my mental model of a large language model be? And so what we really want to emphasize that a large language model isn't just one AI system. It is a collection of tools that includes AI systems along with more traditional tools that are combined together in a way that usually it ends with some little interface that we can chat and put input-output in a typical chat response.
So give me an example of what interacting with a large language model looks like.
Yes, and it's, I grew up during the AOL Instant Messenger days, and so in a lot of ways, it reminds me of that. You put in a response, I put in some input, hi, how are you doing? The output takes in the context of what I gave it, so the large language model will be able to take that and respond to that in a contextual manner. I'm doing well, thanks, how are you? And then the neat part about these is that they're really extended since those way back when days of just in the early 2000s, and can really take in the context over a long period of time and be able to respond in a seemingly very intelligent manner, definitely a very fluent conversation.
So I love that you just used and put special attention on a seemingly intelligent manner. What's actually happening behind the scenes there? Why is it seemingly intelligent and not just pure intelligence?
These models are very exciting tech pieces of technology, and exploring them has been a lot of fun. I think at the end of the day, I'm really grateful for my background in statistics, which really makes me think that there's a lot of randomness involved. And that's very true for these large language models. So these large language models are really awesome in the sense that they have seen so much information. They pretty much read the entire internet. But at the end of the day, how they respond are based on those patterns of information that they have learned. So they're very, very good at predicting what the next word or even sequence of words is going to be. But that is completely based upon all the previous texts that it has seen before, along with some guardrails and other reinforcement learning that have been added to really make these systems appeal to humans.
Fantastic. I just think breaking it down a little bit is always helpful as we set the stage for a conversation. And so you also mentioned, or you gave a quick, you alluded to Mayflower, the project that our team has recently pursued that was about examining the potential use of large language models in national security, and in particular, the intelligence community. Could you talk about the motivation for that work?
So it was an exciting time, and as you said, GPT-4 had just been released, and before that, just a few months prior to that, ChatGPT was released. So large language models were really in the mainstream. There was a lot of buzz about them, about what can we do with them, how can we use them, how can we make them work. And so this included the White House as well, and they were interested in how they could use large language models for government use cases. So the White House asked ODNI, the Office of the Director of National Intelligence, to figure this problem out. And as a trusted collaborator of the US government, SEI was then tasked with trying to figure out how we can use large language models for intelligence reporting specifically.
So you are sitting at your desk, I'm picturing, and the prompt comes in saying, hey, Shannon, we need your team to start to understand how can you use large language models in the context of national security. Where do you even start with a prompt like that? How do you start? What were the initial steps that you took to get that work going?
This was a massive effort, and it really, at the time, was a all hands on deck effort because as I hope to explain, or not explain, but discuss during this conversation, is that this is an interdisciplinary effort. This is not just one person or even a few people getting this to work. It took our infrastructure engineers, our software engineers, many, many research scientists, and also our responsible AI researchers as well. And first of all, we had to coordinate everyone. So getting everyone on a schedule and then devising a plan. One of the most important things for our purposes, at the time, there weren't very many publicly open foundational models available, which are the large language models that companies, organizations, or institutions have poured in either sometimes millions of dollars, sometimes even much, much more than that, to create these very fluent, large language models. And so we wanted to be able to research and experiment with them. So step one was trying to figure out which foundational model we wanted to use for our purposes.
And so how did you make that? My two follow-up questions on that are, how did you make that selection? And then also, what does experimentation look like? What were the types of experiments that you and the team were running?
The first one of what did we end up using and how did we get there? It took a while, and we did a lot of research. We've read a lot of articles, both on the mainstream, on computer blogs, and also in the academic literature to really see what was available that would suit our purposes. And we had a number of constraints. For example, we wanted to be able to tinker with the architecture of the system, which meant that we needed a model that was publicly available. So already that meant a lot of the proprietary models like ChatGPT were not possible. So we had to look at the ones that were publicly available. So that was a big constraint. And then after that, we looked at a variety of both infrastructure, like what GPUs we had to run these models and how much space we needed. We looked at cost projections for if we wanted to train these models further, about how much we would expect that to cost. And then finally, how well they did compared to other large language models. And fortunately for us, there were a few websites with leaderboards, basically, of how different publicly available large language models performed on different little tests. And so from these, we were able to discern which of these at the time was best to start to use.
And so, as you're thinking about from the research angle, engineering concerns, cost concerns, really technology adoption concerns for the government customer, I'm sure you're also holding in your mind potential use cases. The design thinking professional in me is always thinking about being human-centered. So as you were starting the research, what were the use cases that you saw for large language models in the context of national security?
That's a good question. And it's something that really developed over time. Fortunately, we were able to start with that use case of how can we use this for intelligence reporting. And ODNI was incredibly helpful in that idea generation. But talking with other government customers, with other researchers, we were able to determine a number of avenues that we thought were useful for large language models. And that included code generation, synthetic data generation, interfacing with knowledge management systems, and writing, querying, modifying, and summarizing documents, which is especially the use case that we found with ODNI. Besides that, we also found there was a lot of interest in government communities about wargaming potentials with large language models.
And as a follow-up to that, I know in the work we do with government customers, there's a myth, right, that's perpetuated that government is slow to adopt things, but I'm already seeing a number of folks not just experimenting with the use of large language models, but actively integrating them into their workflows. And so I was curious what your perspective is. To what extent, from your research, did you see that large language models were currently being used in government?
Yes, so we found that as well, and it's definitely very exciting. Maybe compared to previous technologies, large language models are something that I think are quite accessible, and people really have an appetite for them. So they want to be able to use these technologies in their current work. And informally, these tools are very, very easily accessible, usually requiring an email or even less just to be able to use. So I have personally talked with a number of colleagues and who use them for idea generation, for writing simple emails, and helping with writing code. So right away, those are ways that people can immediately use these large language models. I think in more formal ways, those have also been being integrated fairly rapidly. And there's a number of tools that are available for government purposes. There's a very big question of what sort of information can I input into these large language models? And so that is obviously of very big concern, especially because these large language models can touch national security purposes. And so there are a few tools, a few that I'm aware of are Ask Sage, which integrates a number of AI platforms, including Microsoft's Azure and OpenAI. So you can use them for CUI, which is controlled and classified information. And that allows for different documents that these foundational models haven't seen before and to allow for customizations in them. There are also platforms like AWS's GovCloud, in which, for example, that we've been utilizing to be able to run these large language models on the cloud. I don't think there is one standard way right now at the moment to use these for government purposes, but that a lot of development has occurred between May and now, and we expect that to continue, especially with accessibility. I wouldn't say that they are the easiest to use right now for government purposes, but are definitely being developed to get there.
Yeah, so let's go into that a little bit deeper. You made a comment saying that there's a lot of questions right now about what types of information can I input into a large language model or tools built on top of large language models. And I know that you and I in the past have talked about that our customer needs sometimes conflict with the qualities of most large language models. Could you give me an example of why that is true?
Yes. So, one thing about large language models is that uh, they generally remember what you tell them. So, if you put in sensitive information, that's going to usually go into its database, and perhaps will even learn from it. And that means that it's quite possible that that large language model can use what you put into it to tell other people. So you can easily imagine there could be all sorts of concerns with sensitive or PII. And so it's very important to only put in information that you are sure is at the level that the system can handle.
Absolutely. What are some of the other concerns that folks should be thinking about when it comes to large language models and trust in the context of national security?
Yeah, there's a lot of them. So as we talked about a little before, there's a lot of randomness involved in with these large language models, and they appear very fluent. But as we know in our personal testing, we see a lot of what's commonly known as hallucinations that occur, which is information that the large language model is just kind of making up. And so we've seen a lot of alternative histories being written by large language models. And for more concretely, for example, we'll ask about a certain researcher who's fairly publicly known, and it'll start making up titles of papers of this researcher that don't actually exist. So that it and sometimes, but it's very convincing sounding. So it sounds like this person could have written these papers, but they do not exist. So it's very fluent and can mimic human speech, but to actually verify the contents of its information requires much more work.
Yeah, one of the things that we, of course, know is just test and evaluate. The field is moving so quickly that practices for test and evaluation really are in a reactive mode because the technology is changing so quickly. And that's just one of the engineering challenges that exists with large language models today. And so, you mentioned before that you lead a lot of our AI engineering efforts. Of course, OD&I is one of the primary supporters in our work to grow the field of AI engineering. So I was wondering if we could turn now and talk a little bit about some of the engineering challenges in leveraging large language models for national security use cases.
Yes, so I'm glad you brought that up because as one of the principal engineer on our effort, Andrew Mellinger, he has a laundry list for us. But at the heart of this, every step in the AI stack, basically, from all the way down at the ground level of the hardware, and then all the way to the top where people are interacting with this. there are challenges to determine, first of all, can we trust the output of the system? Is it working as intended? And how, if any, because it isn't always AI that is causing potential issues with the system, but how can that potentially add to the number of evaluations and verifications that we have to add to the system?
So to build on that a bit and talk about some of the other engineering concerns, I want to go in two directions. So one is a technical question, which is in the summary paper that you published, which of course we'll link to in our transcript, you recommended that government agencies should consider augmentation of foundational models instead of fine-tuning them. Could you talk a little bit more about that recommendation and what are the implications it has for different stages of that AI stack or different components of the AI stack?
So, like you said, one thing that we recommend currently is to use augmentation or orchestration over fine tuning. And the reason behind that is very practical. Right now, we do not have the available tests and metrics to really determine the effectiveness of a large language model after it's been introduced to new data. And so the result is we're right now without those metrics and evaluations, we know that fine tuning generally is a much more costly endeavor than being able to use orchestration, for example, retrieval augmented generation, which is called RAG, which is sometimes you can think of it as a search plus prompt engineering. And so that is a very less costly tool that doesn't require further training of the model. And so those are two different avenues to customize a model. But and we know they both work to some degree, but trying to determine that quantitatively right now is very difficult. So instead of potentially wasting money on something that we cannot verify at the moment, it is more practical to use the less costly procedure of augmentation.
So I think what you're talking about too is that, yeah, there's a need to have the metrics evolve over time, but you also had said, which of course we know because we live in the world, that the field has advanced since when this work started in May. And so I was curious if you could talk a little bit about some of the main technical improvements that you're seeing or engineering improvements and how that would make you rethink any of the elements of the work done in the project.
Yeah, so there's been a number of improvements that have occurred over these efforts. At about midway in the project, we had a new model that was released every week, so that was an effort to look at. But definitely, augmentation and orchestration is really starting to play a big role. We see a lot of companies really starting to endorse this method of customizing the models. And I think in a lot of ways it's because currently it is a lot more easily verifiable because it implements tools that we traditionally understand and can verify and just uses the large language model on top of them to create improved results. So I think because we trust the parts within it more, it's easier to handle having that result as an output.
Before we talked about, I think what you're hitting on here is so many of the intricacies and interdependencies between different engineering components of the system. And before you had mentioned this was a whole team interdisciplinary effort. And so I was wondering also in light of the technology changes, could you talk a little bit about how you're seeing the skills needed to engineer large language models evolve over time?
Yeah. So one thing that we learned is that large language models can be very persnickety in a sense where that they can give you a very good answer, but usually require a lot of coaxing. And I think that more formally is known as prompt engineering, of what to tell the large language model so you get the output that you want out of it. And so that is something that is both of a concern, I think, to our government customers, but also just from a research perspective, it's very interesting of how do I educate the user and how do I assist the user in creating prompts that eventually elicit the response that is most helpful to the person. And so that is something that has also really come apparent. And you can even see job resumes now for prompt engineers.
Which I always find so fascinating because in my world, framing and reframing is the heart of the innovation process, right? Being able to see and ask questions from a variety of different perspectives. And I think it's interesting. There's a lot of experimentation happening with prompt engineering today. And I completely agree with you. It's going to be an area of growth as people think about how are the questions I'm asking driving different meanings and driving. I love that you use the word coaxing because it creates different responses based on how you frame the question. Within that response, you also brought up users. And ultimately, if large language models are to be used in the context of government, they also have to be usable. And so could you talk a little bit about some of the barriers today to adopting large language models in our everyday workflows?
In some ways, I think there's an adage that goes for large language models pretty well, that they're pretty simple to use and very difficult to master. So it doesn't take a lot to be able to say, hey, how's it going, large language model? But to be able to tell you about the current political climate or recent events in a city, it can require a lot of special wording to be used. And so in that way, there's some learning curve. So pretty easy for anyone can hit to, especially for recreational purposes, can you write this funny poem? Fairly easy to do, but to have it, to be able to trust the output of that, I think is where the majority of the work is going to be with the large language models. And so when we actually need to know if it says like this and this happened on this date and in this location, we need to be able to confirm that as a result. And right now that takes a lot of human manual verification.
Absolutely. So if you were a government leader, say you ascended, right? And you had a team of government folks working for you, or you had the opportunity, which we do all the time, to counsel government leaders saying, hey, what should I be telling my team? What should I be telling my managers? What do they need to know about large language models? What are the one or two factors or elements about large language models that you wish the general public and especially government employees understood better?
I think there's a lot of overlap with cybersecurity here in that I think they can be incredibly useful tools, but require a dose of skepticism with the responses. So don't believe everything that the large language model says at face value. Try to verify it from other sources, perhaps even other large language models. And the other thing is, I really do think they are going to be helpful technology, even if it ends up just being something as simple as writing emails or scheduling events. I think that still would be a very incredible time saver, and there are definitely more potential applications for large language models. So I guess that's two things. Like right now, I think use, but cautiously. But also, I don't think they're going away.
Yeah. I mean, we're all using them every day, whether we realize it or not, in our Google searches and our email responses. And yeah, I think people forget that the DoD is the largest employer in the US, if not the world. So some small change in a person's day-to-day workflow, even just generating some text for a simple response, at scale, that can have transformative productivity effects. And I love thinking about the implications in that way. For the Mayflower paper that we mentioned, that of course we'll link in our resources, you had a bunch of recommendations included in that and guidance for government agencies starting in this field. I'm curious, any others that have popped up recently? What are you reading, learning from, etc.?
One thing that we've noticed in the past few months is that there's a big question to the cost of large language models. And I think the initial number can be really daunting, especially when you hear about GPT-4 and such, where those very, very hundreds of millions of dollars sums are used. But what we have found, due to a lot of the community of researchers and other individuals who just like to tinker around, for at least for a research perspective, a lot of these techniques and abilities are very, very accessible on quite small computers and only that needed a few people. And that includes document collection as well. So if your organization has, just a few documents, you don't need thousands of documents. It's great if you do, but if you have 25 documents that you want to be able to explore with, this is still something that's quite accessible. So I think that we were originally thinking that we were going to spend most of our budget on computer resources, but with some careful thought, because I think it still is easy to spend that money very quickly, but with some thought about what we want to use it on and trying to come up with the research question first, we actually think this is very accessible for smaller agencies as well.
I love that. I think there's such an intimidation factor often, both in terms of the usability, but also, in the resourcing. And knowing that experimentation is accessible is huge for organizations, especially ones that are not technology-first organizations. So glad you shared that. As you mentioned, of course, the field is evolving every single day. What are the big questions that you're pursuing in your research right now about large language models?
Yeah, so part of the AI division, one thing that we're very excited about is that we have a new trust lab. And I think ultimately what we want for large language models is for their implementation in a trusted manner. So I think towards that, we're working with our infrastructure engineers and the other scientists and trust researchers, is how can we make better metrics for these large language models for our government customers specifically. So right now, a lot of metrics, I've referenced a few of them, but right now they're like tests basically. And so that can be awesome if your large language model can perform very well on the SATs, but maybe that's not directly applicable for our government customers. So how to evaluate these both mathematically in a rigorous manner, how can we visualize these results better, and ultimately, how can we better explain the outputs from these large language models to our customers? And I think a large part of that is going to be through augmentation, where we force the large language model to, quote, show its work and either cite its sources or reason step by step instead of just outputting an answer without any context.
Awesome. Shannon, thank you for talking with us today. We'll include links in the transcript to resources mentioned during this podcast. Finally, a reminder to our audience that our podcasts are available every place you download podcasts, as well as the SEI's YouTube channel. If you like what you heard today, please give us a thumbs up. Thanks again for joining us.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.